Hi there! In case you are having a hard time with our multiplying fractions work, I am recording this video to either help parents or students who are having a hard time or were absent. So today we started working on these pages. It's lesson 1.4, starting on page 439. So let's take a look at the first question here. The Astounding Race is a bicycle race that is 100 miles long. Lourdes is going to ride in the Monster Bicycle Race, which is 2 4/5 times as long as the Astounding Race. How long is the Monster Bicycle Race? So, the important information here is we know how long the Astounding Race is. It's 100 miles. And it sounds like our question is, well, we know that information, but how long is the Monster Bike Race? And it gives us just enough information saying that the Monster Bike Race is 2 4/5 times 100 miles. So if we think about our answer, is it going to be more or less than 100 miles? Hopefully you're thinking it's going to be more. In fact, it's going to be almost 3 times as much, or at least 2 times as much. So writing an equation, which is what it's asking for us to do, the equation would be 2 4/5 times 100 miles. So that is 2 4/5 times 100 miles, and that is going to help us find our answer. So there are several ways that we can tackle this. One way would be to use fraction bars, which we've had some experience with. So we could use the pre-printed ones, or we could even make our own right here. So if this fraction bar represents one of the Astounding Races, so this would be 100 miles. So that would be one of the 2 4/5. And then here is another one. So this is another 100 miles. And then we need the 4/5 of 100. So we could create another one. But for this one, we need 4/5, so we're going to have to break this up into 5 equal parts. And the 5 equal parts because the denominator of the 4/5 is telling us how many equal groups we have. So let's see. What could we write here? 100 miles would be one time going through the race. This is twice, so that's 200 miles. And then we need 4/5. Now, I know many of you are asking, well, that's great, but how do we know how many miles the 4/5 is? And typically what we do is we think, well, if we've broken up 100 miles into 5 equal parts, well, what does one of these parts, 1/5, equal? And so we could think, well, 1/5 of 100, we could do 100 divided by 5, or 5 times what gives you 100, and that would equal 20. Or you could do some guessing and checking, like, okay, 5 parts, 100 is the total, it equals the one whole. So what plus what plus what plus what plus what is going to give us 100? So there are several different ways that you can come up with the value of each fifth. So it's just like that. So 20 5 times is 100. And since the Monster Bicycle Race is 2 4/5 as long, we can say that the 4/5 is equivalent to 20, 40, 60, 80 miles out of the 100. So altogether, the Monster Bike Race is 280 miles. 280 miles. That is 2 4/5 times the Astounding Bike Race, 100 miles. And if you notice, 3 times would be 300, right? 3 times 100 would be 300. But it's not quite 1 whole, so it seems like our answer is reasonable. Okay, so that is how you do number 1. Now I did mention that there are other ways that you could solve this, and I will share with you that. So this is the rectangular method, and that is the method that I tend to prefer. Some of you guys prefer the, what do you call it, the number line. So the number line could work like this being the start of the race, so we haven't gone any distance at all. This could be one of the races. So 100 miles is here, basically. This is 100 miles. So this amount from here to here would be considered the astounding bike race. It's only 100 miles. But since the astounding bike race is 2 4/5 of those, so here's another 100 miles from here to here. And then the 4/5, so that means we need to divide up this whole into fifths so we can just look at the 4/5. So 1/5, 2/5, 3/5, 4/5, and 5/5. So just like that. So that would be 1, 2, 3, 4. Right here would be your 4/5, like that. And then the same goes, so we know that there are 5/5 in each hole, and since we're working with fifths, it's kind of nice to stick with that. And the way that I tend to work this out is to show the jumps. You can either do it on the top or the bottom, whichever works for you. And you're going to jump 2 4/5. So here would be your 2, which is 200 miles, and then 4/5. Boop. So here we're kind of faced with the same problem. Like, how much is that? We know this is 100 from here to here. This is 100 from here to here. But how much is each fifth here? And that's where we have to do sort of the same thing, is say, well, if this is 100 miles from here to here, and we're dividing it up into 5 equal pieces, 100 divided by that 5 is 20. So that means each fifth is 20. So altogether, that would be 80. So 100, 180. So the total would be 280 miles. Like that. So that is the number line method. Similar, but slightly different. And then, as I've been showing more recently, is the traditional method. And that feels pretty easy in comparison because you're not having to do the work of showing it as a representation, a picture. So the traditional method, you would have your equation what am I doing? Let me try that again. 2 4/5 times 100. And typically what I do is I will, if there's a mixed number, I will change that into an improper fraction. So to do that, you multiply the denominator times the whole number, so 5 times 2, which is 10, and then you're going to add the numerator, so 4. So 5 times 2 is 10, plus 4 is 14, 14 fifths. So you put that over the denominator. So now you have 14 fifths, which is the same thing as 2 4/5, times 100. And we talked a little bit about how to do the traditional method the last couple of days. And in order to do that, what you would do is take your whole number and you're just going to make it into a fraction. And so in order to do that, any whole number can be written over 1, because 100 over 1 is exactly the same value as the whole number on the top. So for example, 3 over 1 is equivalent to 3. And really, if you remember, fractions is just division. So 3 divided by 1, 100 divided by 1, they are all equivalent to the numerator. So we haven't changed this fraction. And then once you do that, all you do is you multiply across. So 14 times 100 is 1400. And then 5 times 1 is 5. So once you have that, then you need to reduce this fraction and create an create a mixed number. You never want to keep it in the improper state. So how do we do this? There are a couple different ways. You can ask yourself, well, how many times does 5 go into 1400? Something that's a little bit easier would be, well, how many times does 5 go into 14? And then notice that there are a couple of extra place values here. So if I was thinking, okay, 5 goes into 14, let's see, 5 times 3 is 15, so that doesn't work. 5 times 2 is 10. 5 times 2 is 10. And then, what would you have? Oh, you're going to have a remainder. So you have 4 left over, and then a 0 and a 0. So can 5 go into 40? Yes, it can. It can go in 8 times with that extra place value, so 800. No, sorry, 240. So let's see. And 4, bring down the 0. 8. 8 times 5 is 40. Oops, running out of room. And then the extra place value. So 280. Did I say 240? That was weird. So 280 is what 1400 over 5 is equivalent to. 280. Sorry if I confused you with the 240. It is 280. So, you know, in one sense, this is easier. You're not having to draw these pictures. But in another sense, it can be trickier because your numerator is so big. So if that doesn't bother you and you know that a fraction is just division, so the top number divided by the bottom number, then you can do a quick division problem and figure out what is that equal to. In this case, it's a whole number. There's no fraction, so it's pretty nice and easy. So you notice that the answer is 280 in all 3 instances, 280 miles. So those are the 3 methods that we're using in class. We started off with the visual representation of multiplying fractions, and as we've gotten pretty good with that, a lot of you are moving into the traditional method. But again, if this is at all confusing to you, it really is better to stick with one of the visual models until you really, really understand that, because this you can always fall back onto. So that is number 1, believe it or not. I will continue with another one, but first I'm going to pause this video and upload it so you don't have to listen to another 13 minutes if you don't want to. Thank you for listening. Let me know if you have any questions. Thanks.